So I think let's just move on while others join us. Okay? The meeting was scheduled for 4 o'clock. Good afternoon to everyone. My name is Lawrence. You hear me just for the message in the chat so that I can remember to put on the chat. Yeah, if you can hear me, you can drop the message in the chat. Probably an emoji or two so I can know we can all hear you. Okay? All right. So let's move on. Something on production machine learning part. We just want to take your model beyond the PC, beyond the typical notebook, beyond your working environment to production. These are actually been ability to recover productivity. So it's very critical now to take your model into production. Alright, so and that is why we decided to be having a series henceforth on productionizing your machine learning models. Session for the series, we're still gonna have another one in January and subsequent. Alright, so I welcome you all once again to this session, and let's enjoy the rest of the session. So, but just before we move on, I would like to introduce Okoyemi. Alright, Okoyemi is a machine learning data scientist. Most of you know about him or how to build machine learning or how to build machine learning models using a series that comprises of different attributes and further multimodal functions. These are the part of it. This means you really have the expertise to implement this kind of topic in intellectual matter. All right, so okay, over to you.
Okay, thank you so much, Lawrence. Thank you for that. So, before we deep dive into what we have today, I will just quickly share my screen. So, you got to permit me to share my screen. Can everybody hear me? If you can hear me, just signify on the chat session or so. Okay, thanks. So, I'll be sharing my screen now. Please, can we confirm we can see my screen? Okay, great. So, this is what we have for today. I'm going to go into presentation mode, and again, you're welcome to this session, production machine learning models. Of course, I believe that 90% of people on this call can at least build a machine learning model. So without further ado, let me quickly introduce you to where I work, Data Science Nigeria. Okay, so Data Science Nigeria is just a company, a non-profit organization with a vision to raise 1 million AI talent in 10 years. And I believe that 50% of the people on this call are already part of this dream and vision of the company. Okay, so part of our achievement in the company is that we have been able to distribute over 17,000 plus of uh, um, 70,000 plus of knowledge box, which comprises of different machine learning videos, resources that you can think of. We also have 1 million plus direct download of our free artificial intelligence startup notebook. Also, we have some content on our YouTube channel, so you can always check it out and have a view of what standard resources you should be looking at in machine learning. Okay, part of our dream, part of the company's goal is to contribute greatly to data science and AI application in social good. So regarding that, we're able to secure and won an award, Matai Award, at the Deep Learning Indaba in 2019, which is one of the biggest artificial intelligence community. Okay, we also won the Best Poster Award at ACM conference on economics and computation. So all these are based on artificial intelligence application for social good, and we're also recognized at the world largest artificial intelligence hackathon, Tunisia 2019. Also, these are These are founder Dr. Olubayo Adekobi speaking at world number one scientific artificial intelligence platform in US. Okay, so we run the biggest free AI learning platform you can think of in the on campus, city, for kids, for professionals as well. And if you look at the breakdown of this, you can see that for the beginners, we are looking at AI Wednesday, AI invasion, AI everywhere. Even for kids in primary school and even in secondary school, we have a program for that. Okay, so I won't bore you with this. And part of the program that you are currently joining now is for the university and professionals. And DSN AI Plus Club Futa has done a great job on this. So all over Nigeria, we have several university campus AI clubs, which are, if you're a student of university, you can join anyone on your campus. This is the amazing team behind Data Science Nigeria, and one of our biggest events of the year is always the boot camp, and you can see the number of people represented at the boot camp. So this is we just concluded the year 2020 boot camp version, and 2021 will be bigger, I hope. Also, we also run professional analytics for practitioners in the field. These are an example of that. We have training at the hub, so feel free to come to the hub and make use of the resources available. This is Sarah Uka at the hub while she was giving what is it called? She was given a with machine learning session with pre-university students. You know, so this is the knowledge box with a lot of resources in it. Okay, so AI for kids, AI for kids as well, and also the first artificial intelligence book for primary and secondary school. This is something you can gift out for Christmas for your junior ones, for those that are just coming out in this industry. So you can get this book on this platform, Amazon, and Google Play, Jumia. It's all available there. This book is very, very good for starter. Okay, this is a book secured multi-global endorsements. These are top frontiers in AI that have recognized this book. If you want to know more about the company, you can visit the company website and Twitter, Instagram, Facebook. Okay, so today we are looking at a production machine learning model, and we will look at the workflow and possibly look at some basic examples so that you can get that model from Jupyter Notebook into production. Okay, if you want to follow me on Twitter, this is my handle. This is my handle also on Medium, and this is my name on LinkedIn. Okay, so what are we going to be doing today? We are going to deep dive into production machine learning model. We are going to look at machine learning models and the development. We're going to look at MLOps versus DevOps, which is very, very important. We're going to look at deployment options. What are the options available for you when you want to deploy your model to production? And most importantly, architecting production machine learning model. This is the most crucial part of the job. You want to make sure that you have a blueprint of what you want to deploy before you even start implementing. Okay, and we're going to look at some post deployment activities. You know, after deployment, what next? Does it just lie there and user interact with it? Okay, so we're going to deep dive in this direction, and if you can still hear me and were with me, can you just signify on the chat session and just type something or so? Okay, thank you for that. All right. If you look at machine learning in broad, before we move into production machine learning model, you'll see that we have supervised learning, unsupervised learning, and the likes of it. And whichever model you want to deploy today, one of them falls under this category. So the kind of choice of deployment you are choosing or how you want to productionalize your model also align with the kind of model you are working with, the kind of problem you are trying to solve. I believe 50% of people on this call are familiar with this. Okay, so if you look at machine learning model development, let's start from there. You'll see that there are a series of units and iterative processes that involve in this activity based on the data you are working on and the kind of data you can work on. are like tabular data. I'm very, very sure that majority of us has worked on tabular data. In fact, that is the like 60% of problem in machine learning lies in tabular data, something on spreadsheet, Excel sheet. We also have image, sound, and video as well. This is a typo. And the workflow for today, we will not be discussing system one. This is system one, system two, up to system four. So we are starting from system 5 and system 6, which is where we are productionalizing our machine learning model. If you notice, you'll see that system 1 is all about building the model. You are building a model, and this lies in maybe like Jupyter Notebook, a Colab or something. So you are performing an iterative process here. System 2, you are splitting the data. System 3, you are building the model and you are training at scale. We're going to talk about how you can also train at scale. It's very, very important. But system 5 and system 6 is the focus for today, because mostly people tend to stop at system 4, because once you just finish that model on your Jupyter notebook or so, you believe that you've built the best model, but how do user interact with that model? Very, very important. Now, if you look at it from ML workflow, if you look at it from ML workflow, you will notice that there are different output for different units in the team. For instance, we are starting with research and development phase, which is when you want to build an ML app, it always starts with research and development phase. Okay, so if you look at the research and the development phase, we have the researcher and the data scientist. What do they do? They gather data, they perform EDA, they define the problem, they build the model, and the final output of their work is insight or saved model. Insight, saved model, or pipeline. Okay, so this is where the work begins when it comes to productionalizing machine learning model, because you've built a fantastic model, you've been able to gain insight, bring the best insights from the model, but and also save the model if possible. But when user want to interact with the model, they can't come into the iterative process you've done here. We have to, in a way, replicate this for their data and give them prediction. So if you look at the development integration, which is a work of machine learning engineers, similar to that of software engineer, you see that the workflow here is the machine learning engineer has to work around the app source code, has to look at the input processing, model, pipeline, testing, deployment, and automation. And this is where our focus is today. The output for this is either API or ML powered app. All right. Okay. So if you look at from this research and development phase, the output is saved model or pipeline. So how do we save the model or the pipeline? They are different formats, right? So if you look at it, we have framework specific and we have multipurpose. For instance, if you are using TensorFlow to develop your model, you have the save model option. If you are using Keras, you have the HDF5 file. If you are using PyTorch, you have the .pth file. There are many of them depending on the framework you are using, depending on the framework that has been used in the what in the research and development phase. Also, we have the pickle. This guy is very, very what is very, very popular. Everybody want to pickle their model because it's the easiest, right? And also we have Onyx and PMML. Onyx is by Microsoft and it is multi-purpose. Any model from any framework can be saved with Onyx. Also PMML. So now that we have a saved model, it is now left for us to deploy the model so that users can use the model, isn't it? Before we start looking at how to deploy this model, I want us to quickly look at MLOps and DevOps. This is very, very important. MLOps and DevOps, they are interwoven professions like machine learning operation and development operation. They are very, very similar, and there are some things that are common to both, and there are some things that are what different, I mean peculiar to each of them. Now if you look at the workflow in MLOps, this is a simple MLOps workflow. If you look at, just follow the arrow, you see that we have training. First of all, we need to design, right? From designing, we move to training and testing, and from there we deploy the model, then we maintain the deployed model. Can you see that our focus here is not on training and testing? We are working on deploying the model and maintaining the model at production, right? And you see that this is a continuous process. After deploying the model and you are maintaining the model, for you to optimize that model even in production to release version 2 or version 3, you have to go and redesign the process again. So sometimes, and if you look at the DevOps phase, for the DevOps, also follow the arrow. You notice that we have to plan first. After planning, we code, then we build, we test, we release a version, then we deploy it, we operate on it, then we monitor it. So there are some phases that are common to these two. For instance, there's deployment here, there's deployment here, right? So there's testing and training here. You also test here. There's nothing like training in the DevOps because we are not leveraging on data in DevOps, but in MLOps, we are leveraging on data, right? Okay, so let's take this further. I like this particular image because it explains the similarity and difference between these two professions. Because if you look at DevOps principle, we can say that DevOps principle also apply to MLOps, but there are some aspect of machine learning workload that require a different focus and implementation. For instance, you can look at the tail of this. We have production, and you can see that the beginning of this part is also production. So even after production, we still go back and redesign, which is what this is telling us from here, that after deployment and you maintain, you can still redesign your work. Okay, so for before we get to ML and development, we need to work on the data. We need to identify the data, collect the data, process the data, store the data, and we have requirement for the model we want to train. And in the model training, we explore, we extract, we train and optimize, right? Now, if you look at the development, this is development, this is DevOps, and this is MLOps. So development, we plan, we develop, we package, and we test. And then we have staging. So the operation here is for both development and for both DevOps, development and machine learning. So this operation here is for the two of them, right? Because after machine learning model has been trained, we need to validate, release, configure, and monitor. When we are monitoring, we are already in what? In production. So if you look at the two very well, you see that we can say that DevOps principle also apply in what? In MLOps. Just that there are some aspect of machine learning workload that require different focus on what? Implementation. Okay. Now, if you go in depth into the differences and similarities between these two, you will notice that from the objective, MLOps aims to manage deployment of all types of machine learning in large-scale production environments. That is the objective of MLOps. But for DevOps, we are looking at merging development, quality assurance, operation, which is still deployment and integration, into a single continuous set of processes. It is natural extended of what? Extension of agile principle. I believe we are familiar with the agile principle. Okay. Also, if you look at the team skills, the team required the team you have in MLOps and the team you have in DevOps, for the MLOps, we have research scientists, we have data scientists, we have data engineer, machine learning engineer, and the machine learning engineer is just more like a software engineer that takes your build model into production. But if you look at DevOps, we have software engineer, we have software developers, cloud engineer, architect, etc. There are many of them too. So the team skills also, there are some similarities and there are some differences there, right? Also for development, when we are developing in MLOps, MLOps is experimental. Like you don't know the end product. You just know that this is what you how will I put it? You know that at the end of the day, the user will be getting prediction. But the process of the user getting prediction is iterative. So it is experimental and iterative. But for DevOps, it is linear because what you are building, the software you are building is you know what you are building already. For instance, if I'm building a weather API, for instance, of course, my weather API should be able to, predict the weather condition for a particular region. So I know, to forecast the weather condition of a particular region. So I know what I'm building. So I can write a lot of tests around that and even leverage on existing APIs. But the reverse is the case when it comes to MLOps, right? Because you don't know the end of what you are building. It is experimental. You are experimenting on something, right? Also, if you look at the testing in MLOps, it is in-depth, right? It is specific because you have to look at the data validation, you have to test your data, you have to test your model, you have to test the integration of the data and the model, but for DevOps, tests are subjective to the expectation of the code. You have a demand that what the software you are building, this is the function of the software. So when you're testing, you already know what you're testing against. But when you're testing in MLOps, you're testing against the data, you're testing against the model, you're testing against what's it called? Bias, you're testing against the integration of of different units. Okay, sorry for that. Sorry, like someone is muting and unmuting himself. Excuse me. So, if you look at the deployment now, for the deployment of both, we have it to be similar, right? Because after we've gone through the development and everything, for when it comes to deployment, they are similar, just that the deployment process in MLOps is similar to DevOps, but it depends on the type of ML system you are deploying. We are still going to deep dive into ML system, which is very, very important. The kind of ML system you are deploying depends on the kind of approach you're going to adopt for the problem you're trying to solve. Now, this deployment become easier if the output of the research phase is a saved pipeline or a saved model. But if they just give you the insight and they ask you to deploy it, what are you deploying? You have to go back to rebuild the model and deploy something. So what you are deploying is actually a model. You are deploying a model or a pipeline, right? Now, also the production. When it comes to production ML is continuous and can be more challenging than what traditional software, because after you've deployed your model, right, you want to think about how your model is behaving in production. For instance, if I've deployed a software that can crop picture from a larger size to like 2:5 to 2:5, that is, I'm talking about DevOps now. So I've been able to deploy that software and forever and ever, except I want to change the principle of what I want to do. It is the same thing, just upload your picture and crop it and download it back. But when it comes to machine learning in production, depending on the kind of data you give, you get prediction. And with time, the machine gets degraded from the kind of data you are, from its performance when you are uploading different data, isn't it? So it means that you need to redeploy different models as time goes on. So that's why production in ML system is continuous and can be challenging because it is not static. For in a year, you can have like 5 versions of your models in deployment because you are trying to overcome bias in any way, because what you're doing is prediction, right? Okay, so with this, you can also read more on the differences and similarities in MLOps and DevOps. Now, when it comes to deployment options, right, we can deploy as a service, which is a decoupled system. I'm going to explain what that means. Or we can also deploy as an ML app or embedded system. These are the two options commonly that you can find out there, but there are several ones as well, complex one. But these two are majorly they are majorly used. So when you're deploying as a service, this is more like software as a service, but now it is ML as a service, a microservice. What it is, a decoupled system, like what want to consume your ML service is decoupled from your ML, right? So what you are deploying is an API. You are deploying API. you're not deploying an ML app. You're not deploying an embedded system in an existing system, or you are deploying a published package. What do I mean by that? I believe everybody know the meaning of what's it called, API, application interface, right? So if you are deploying as a package, like everybody should know something like PyPy, or how we download pandas from PyPy, how we install NumPy and the likes of these are packages. You can also deploy your machine learning model as a package. Then any integration, I mean any system that want to integrate it can consume it, can download it. So that is a decoupled system, right? Also, if we are going to explore this option, and also if you look at deployment as what ML app or embedded system, it is a tightly coupled system. What you are deploying is already integrated in the system that want to consume it. So for instance, you can deploy as a standalone web application or mobile application. So if I have a mobile application, for instance, and the ML model is already embedded in the application, so that is a tightly coupled system. So if I want to update that kind of model, I have to update everything, both the system and the model together, right? But if I want to update ML as a service, I just need to update the API, right? I need to publish another package to maybe like PyPy or something. Then the system that I want to consume it can download it from there. So that is a decoupled system. But in this case, we have a tightly coupled system. Another one you can think of is when you as an embedded AI is already embedded maybe like in an Arduino, Raspberry Pi, on the likes of it. But before we move on, let me just quickly show you some examples that I think will be useful for this. So if you look at this, can you still see my screen? Like sorry, can you signify and by in the chat session? Okay, okay. So if you look at this, this is artificial intelligence powered app gallery. Several models, publicly available models that I just deployed, and there's other ones too. But these are the ones that I can show out there. There are some other client applications as well. But if you look at this, from what I've explained, if I go back to this ML as API, an example of ML as API is this. If I open this now, it opens another tab. Maybe I should just open them one after the other in different tabs, right? So that we can see them. My network might be a bit. Okay, so I'm opening all of them one after the other. Now, okay, so ML as a service, you deploy an API. If I open this towards data science, because this is just an API, we can't consume an API in this what's it called, environment. I just want to show you how it will look like. My network is kind of down. Okay. Okay, maybe we can come back to this. Okay, now look at this. This is ML as a what? As a standalone application, insurance app. If you look at that application, the user can fill in maybe you are a male or female, you can put your age, you can put just fill in all the features, then you get prediction out of it. So this is a tightly coupled system, right? It is coupled in a what? In a web application. It is there, right? We can also make this a decoupled system whereby this web application is consuming an external API that you have deployed. Okay. Now the other one I wanted to show you, this is still loading. Oh, this is still loading. Okay, this is still loading, but you can always check this URL out. You can check this URL out and um, play around them. Okay, so I'll come back to that if my network is stable. Now we are still on deployment option, but before we move ahead, I want us to discuss overview of ML architecture. Excuse me. Now, if you look at ML architecture, I mentioned something around it then, that the kind of approach to how you are deploying your model depends on ML architecture you are what? You are mimicking or you are adopting. So for instance, we can group the ML architecture into four. There are more than this, but we can group them into four. Train by batch, predict on fly, serve as REST API. This falls under what? ML as a service. ML as a what? As a microservice. So this can guide
And
me.
depending the time it comes up, you can just decide to tweet,
Okay.
right? Can tweet at us, Twitter sign is Nigeria tag DSNA across Twitter, and you can also tag Fayemi on Twitter as well, based on what you plan to.
Okay.
Right?
Yeah, thanks for that, Lawrence. So we have we have
Okay, over to you, Fayemi. I think it's back. Mm.
okay. So we have trained by batch. Can everybody still hear me? It's like if you can hear me, please can you signify in the chat session? Can you hear me?
Yes, you are
Oh,
audible.
okay, okay. So let me move back to that. Okay, I say we can train by batch, predict on fly, and serve as REST API. This method has been employed in this particular application, this mortgage app status application. We train by batch, then we can also predict by batch. That is, you have your user instead of, for instance, this one you can only predict once. Like for a particular what's it called, entries you have here, you get a prediction. But when it comes to, you are training by batch and you are predicting on fly, you are serving as REST API, you can decide to also predict in batch. Like you get all your data out, then you predict in batch, unlike predicting one after the other. So for instance, I can get prediction for like 20 people at a go, 30 people at a go. So this particular one can be useful in bank, and that is where if you notice before, like when you go to bank and request for your ATM, let me say like 2016 2017 in Nigeria, you will notice that you can't get instant card because the production is in batch. So your card comes in batch, like it comes with a particular batch. So that is like batch prediction. But now that in 2020 you can go to any bank and get instant bank, it means that they are predicting on fly. It means you are getting your request on fly, and it is no longer in batch. Now you are being attended to as a single individual, right? That is one again. Also, you can look at train, predict by streaming. Well, this is the most difficult one when it comes to ML architecture. Why is it difficult? In the sense that, for instance, if you look at Uber system, they are predicting on fly because they are working on real-time data. But when it comes to like banking system, or like insurance system, or like let's say medical system, they don't need to stream the data because it is based on request. So when a customer come, we get this out. But when it comes to Uber, their data, I mean their system has to be on 247 because they can't tell when you make the request. So they are predicting on fly, and the prediction is being streamed. So this particular one is very difficult because that's where you'll be looking at tools like PSub, you'll be looking at Kafka, you'll be looking at a lot of tools around that area, and the workflow in that particular architecture falls mostly on the data engineer, not even the ML engineer this way now, because it will fall majorly on the ML architecture and the data engineer. All right. So the last one here is trained by batch. Then you predict on mobile or to other clients. So more like you have a gadget, and you've trained the model, then you've embedded the model in it, then you can get your prediction out of the model. So for instance, if I pick up my phone now and I say, "Hey Siri, remind me of a meeting by 4 p.m. today," that is my own Siri, not your Siri, right? But at the end of the day, when Apple wants to improve on Siri, we have to sometimes they gather all our data to improve on Siri, right? With our permission, right? Okay, so these are the different four that I've listed here. You can go over it again, and depending on the one you are adopting rather, that is how your workflow will go. Then you can now move from here and start architecting what tool should go into what tool, which unit goes into which unit, right? Okay. Depending on the one you choose also, there are advantages and what and disadvantages. But I will focus on the what's it called, advantages and disadvantages for pattern one. That is, you are deploying as a RESTful API. It means that you are training as a batch. You are predicting on fly. Prediction result delivered via REST API. But the latency of the permission is, the prediction, it is neither good or bad because you are predicting via API. It means that the system that is making requests to the API has to call the API. So there's some kind of latency there, right? But sometimes if your system is fast enough, maybe you've deployed it to an active system on the cloud, then it is always on. So if I send the request immediately, I get it out immediately. You will notice that when I started this app, it took some time for it to come up, right? So because I've set it up on the cloud that it should get shut down when there are no requests. But when there are requests, when there is first request, bring up the system. If there are no requests within 10 minutes, just shut down the system. So that is where this lies, right? Then the system management is difficult when it comes to you predicting as what REST API. The system management is difficult. At that level, it is neither good or bad. If you look at the pattern two, which is shared database, you are deploying.
Sorry,
Yep.
sorry to cut you short. We can't see your screen anymore. I don't think
Oh,
you're still sharing.
oh, I'm sorry about that. Wow.
All right, please come.
Let me share my screen again. Share entire window. Okay, can you see my screen now?
I get it. Come here.
What about now?
All right. Yeah, we can see your screen.
Okay, I'm sorry about that, right? Okay, so can we see the slide now? Can we see the slide?
Yes, yes, we can.
Okay, okay. So let me quickly rush over this because this is 440. And so I have shared as database, right? Okay, so we can quickly go over this. Now I have this pattern two as shared database, and you are training on batch, you are predicting on batch. Through the shared database, you can get the result. The latency is very high because you are sharing database. You are sharing database. After your prediction, you are sending it to a database. Then those that need the prediction will now need to go into that database and fetch it. No. So the latency is very, very high, right? And the system management is easy because all you just need to do is to put the prediction and push it to what? To the database. So you don't even need to know about what's happening in the system over there. You just make your prediction and push it to database, right? Okay. So this system management is what? Is easy, but the latency of the prediction for the user to get the prediction, it will be very, very high, right? So but when it comes to streaming, you are training by streaming, you are predicting on by streaming. Then prediction result delivery is maybe streaming via message queue. For that kind of system, the latency is very low because as the data is coming in, you're getting your prediction immediately. Immediately, you're getting your prediction. So the latency is very, very low. It means that the delay in the system is very, very low. Also, when it comes to managing the system, then it is very, very hard, right? Because you have to set up every component that will be responsible for the streaming of the data. Okay, so that's one. The system management is very hard, right? For pattern four, you're training on streaming, then you are what? You are predicting on fly, then via maybe in-process API on mobile. But one thing you should know is that the latency is very low, but the system management is neither good or bad. It's neither easy or hard. It is almost the same thing. You have nothing to worry about. So also, before you jump into maybe you want to use pattern one, pattern two, pattern three, or pattern four, you have to think about how your user wants to consume the model. You also have to think about how you want to integrate your model into the system. Do you want to embed it? What kind of solution are you providing? What kind of problem are you trying to solve? So if you miss the right pattern, then you are deploying in the wrong way. Okay. Now, if you want to read more on how this is well explained and the likes of it, you can check this article out on Medium. You can check at Okpeyemi Bami on Medium. So I have it, Deployment of Machine Learning Model Demystified. It is a two series article, part one and part two. You can look into it and get more in depth of how to deploy model on that. Also, when it now comes to inference, we are still on deployment option. Don't forget that we are still looking at what kind of deployment option should we adopt. Now, when you come to inference, that is at the stage of predicting, it can either be static or dynamic. What do you mean by that? When it is static, the prediction is being looked up in a pre-computed what label. I wanted to show you this, but can you still see my screen? I wanted to show you one of the app. Okay, okay, the app are back on now. This one is still reloading, and okay, okay, this one is reloading. Now, this one is a topic model open source tool. You upload your text file and everything, then you generate your result and download it as CSV. You can check this URL out to try and see how the tool was built and how you can leverage on it. Okay, okay, this is the one I wanted to show. Now, this simulates train on fly and train by on stream and predict on stream. Can you see my screen? Okay, now if I change any parameter here, I get equivalent result here, and this prediction changes immediately, right? So in this case, the training is done on fly, on streaming, and the prediction is done on what is done on the fly immediately. You get it immediately, because if I change any parameter here, just watch this diagram. If I change any parameter here, I get a corresponding result almost immediately, right? I get a corresponding result almost immediately. So this one is useful when the kind of solution you're trying to provide is maybe you're monitoring like a cryptocurrency, or you're monitoring a live data. Like you want to see the effect of this, you want to see the effect of this on this model, you want to see the effect of that. So always have it at the back of your mind that it depends on how you want to solve the problem. So you just don't jump into deployment. There are several ways of deploying. Also, this static one that I was talking about, like a pre-computed label, I wanted to show you one app. Where's the top? Let me see. That app should be um, bot tennis, for instance. Okay, sorry, my light is down. Bot tennis, for instance, if you check bot tennis, you are getting a prediction from a bot. Now, when you interact with a bot, for instance, maybe you ask what is the price of this speaker on Amazon, it will tell you the price based on, it goes into a table, look for that particular thing you are querying. That particular thing you are requesting, it queries based on that and gets your prediction out for you, right? Okay, but that is one, that is static. When it comes to dynamic, dynamic in the sense that the label compute is on demand. It doesn't know how the label is. Once you make your request, then it can maybe like classify that this is image, this image is in classification of 0, this image is classification of 1, is in classification of 2. So I don't know if you get the idea of what I'm trying to talk about. So but if you look at it too, also for static, we have high storage cost, because you have to go and store the table. You have to go and store in a database that the bot or whatever the model is trying to query against. So you have high cost there. Then you have low latent fix, you have low maintenance, then space intensity, right? Okay, now dynamic storage, variable, and high maintenance. Those are the characteristics of dynamic what? Dynamic prediction, right? Okay. Now you can look into this more and get in-depth knowledge on that. Now let me quickly talk about architecting production ML systems. Sorry, let me quickly just give me like sorry, I want to mute for like just 30 seconds. 30 seconds, please. Okay, so sorry about that. I needed to quickly do something. Okay, where was I? Now, architecting production ML system. When it comes to architecting production ML system, when designing an ML system, the following should be borne in mind. You want to have this in your mind. You have to look at the modularity. You want to look at reproducibility. You want to look at scalability. You also want to look at extensibility, testing, and automation. What is the meaning of each of these? When it comes to modularity, I have to go back to that. The code you are using, the feature engineering part, the pre-processing part, make it a module like you are writing an object-oriented programming approach. The pre-processing part should be a module, the feature engineering part should be a module, the prediction part should be a module, right? That makes sense, right? Now also when you are looking at reproducibility, you are looking at the output of each component that you've written in modules now. The output of each of them should be replicable in any version. That is the meaning of that. It should be replicable in any version. That is, for any version in time, that result you are getting from that particular component, that component might be like the preprocessor component, or that component might be like the predictor or the trainer. Are you getting my? So it should be what? Reproducible, right? Now, scalability is the sense that the model must be servable to a large number of customers with minimal response time. That is, the latency should be what? Should be minimal. So, when you are designing your ML system, you need to consider each of these characteristics. It is very, very important. The meaning of extensible is that it should be easy to modify for future tasks. Like maybe your client says that your client wants just the prediction. Is this good or bad? Then your model is predicting good, bad, but you've not make necessary what features for extensibility. Maybe your client now wants what is the probability of being good, what is the probability of being bad. If it is not extensible, like you can't easily modify it to adjust to the feature request, then your architecture is not good enough. Your architecture is not good enough, right? Also, you have the ability to test variation of what model version. Then automation is very, very important. Okay, that being said, let's quickly look at the meaning of production machine learning system itself. From knowledge of systems, you can say that production machine learning system is a conglomeration. The meaning of conglomeration is parts working together, synchronization of different functional units together to achieve a common goal. So there are different units in the ML system you are trying to what? You are trying to deploy or trying to what? Simulate. So for instance, if you look at this, this is a unit itself. This is a unit. This data collection is a unit. Data validation is a unit. Machine learning resource and management is also a unit on its own. But your ML code that lies in your Jupyter notebook or Colab, look at how small it is. This is what you've been doing all over. But the surrounding unit itself, the feature extraction, process management tools, configuration, and the likes of it, they have ledger responsibility attached to them, right? So if you look at this, we have according to Google ML unit, ML code account for just 5%. So what you have been coding with pandas, NumPy, sklearn, TensorFlow, and PyTorch and the likes of it, then you build your fantastic model, you save it, it just account for 5% of your production ML system. Just 5%. So the question now is, what unit occupy the remaining 95%? What will I be doing with the remaining 95%? It means there are a lot of activities, there are a lot of units that needs attention apart from your ML code. Yeah, you've built your model, but when it comes to serving that model, there are a lot of things that needs to go into that, right? So if you look at the first thing you need to decide when you are architecting production ML system is you want to decide whether you are going fully cloud, like are you using cloud for everything, both your training and deployment. That we call that cloud native. You're using either Google Cloud Platform, AWS, Microsoft Azure. There are many of them out there. So it means that your training is done on the cloud, your prediction is done on the cloud as well. Your model serving is done on the cloud. So that is cloud native. Or you want to do part of them on your local system and put part on the cloud. We call that hybrid. That is hybrid. But sometimes we want to have on-site or on-prem. The meaning of on-site is that you've trained locally here, you are deploying here, and people are getting results here. For instance, if you apply for let's say voters card, for instance, for voters card, for instance, let me just use that as an example. You go there, you register, you get your card there, right? So that is on-prem, isn't it? Not like it's not like a system is sitting in on the cloud and they are making requests to that to get the result. No, everything lies in the physical premises, right? So you can think of it as cloud native, hybrid, and what? On-prem. So you have to ask your clients, how do this model, how will this model be consumed? Will it be consumed via an API, or you just want a setup system or a dedicated server in your company that you just need to get the result of the model from there, right? So you need to decide on this. So let me quickly move to the next slide. You can look into this. It's just what we've discussed, that we have data ingestion, data analysis, transformation, trainer. The trainer is when you're training the model and everything. So each of these components can live on the cloud. Each of them can live on an hybrid system. The meaning of hybrid system is that you have maybe your data injection on-prem, you have your data analysis on-prem, then you have your data transformation on-prem, but you are training on the cloud. Can you see that? You might be training on the cloud and getting prediction from the cloud. And on-site is everything is done in your physical workspace. Now, also, when you are architecting, don't forget that what we are doing is you are architecting. You want to architect your production ML system. You want to know what goes into what. You are trying to draw an architectural view, a blueprint of how everything will be deployed. So you have to look at the libraries, the framework, the tools that are available to you as well. For instance, am I to use TensorFlow? Am I to use PyTorch? Am I to use sklearn? Am I to use a pipeline, or am I to build a consume module? Am I to use Kubernetes? Am I to use Docker? This one also is very important. Am I to use software as a service or platform as a service? Am I to use GCP or AWS? Am I to use on-prem? In that case, you are trying to discuss the tools that you'll be using. You want to know the tools that you'll be using, and it is very, very important. If you don't determine your architecture and the kind of tools that goes into different units, you might get it wrong in the end, which is very, very bad. All right. So, but the funny thing is that there are levels in MLOps. There are levels in MLOps operation. Now, let me quickly read this to you. The level of automation of data science steps defines the maturity of your ML process. Look at that. The level of automation of data science steps defines the maturity of your ML process. Like, you know that this work is iterative. The data gathering, the training, the prediction is iterative. But the level of how you automate that process defines the maturity of the architect you've designed. You've designed the architecture, right? But I can grade your architecture based on the number of automation that you've done there. Is everything manual labor, or is everything pre-configured to maybe like when it is 2 o'clock, train this model, when it is 3 o'clock, people can start using like that, which reflects velocity of training new models. Because if everything is done manually, it means that for you to train new model, it will be rigorous, it will be difficult. But if you've done a lot of automation there, It means that training new model will be easy just for you to maybe set a trigger on AWS or something. Just put on your system and tap train, then it start training again. Or you set a timer that once it is every quarter of the year, retrain this model based on customer data and let me know if the model is improving or depreciating. So there are three levels to that. We have level 1, level 0, level 1, and level 2. The level 0 is everything is manual process. Level 1 is you are using ML pipeline automation. But level 2 is the highest. You have continuous integration and continuous delivery of pipeline automation. Now, majority of what you find out there is manual what? Manual process. Maybe somebody just built a model, pickled it, and deploy it and serve it via maybe Flask API or let's say Fast API or Django, any API tool you can think of. That is manual process because every bit of the code that goes into that, you have to write it, and it is custom for that problem you're solving. It means that if another client comes from, let's say, like a particular bank now, you can't use that solution you have on a new problem. You have to reconfigure everything again, right? But when you're using pipeline, it's just for you to tweak one or two things. Okay, this problem does not need data gathering. I remove this pipeline unit of data gathering. Oh, this problem requires me to train the model. I plug in training model pipeline, everything like that. So that one is there's a level of automation. But when you're not talking about level 2, you have CI/CD, continuous integration and continuous delivery. It means that almost everything is automatic. Once you do like it's more like start your car and let it start moving, more like a self-driving car. You just start it, or with a command start, and it start moving, right? So let's look at what these three levels actually means. If you look at level 1, manual process, look at this chart very well. You have your data is offline, your data extraction analysis, data preparation, model training, model evaluation. You train the model, then you put your model in the model registry. Then that's the end of your what? Machine learning. Then the operation is where you are serving the model and you are predicting, right? You are using a single workflow for both training, but when it comes to predicting, you have to replicate this. For instance, listen again. The experimentation that you've done yet, maybe you've done like change the date to this, change the year to this, change this to that. All the processes here, you've done it in your Jupyter notebook. When it comes to when you are deploying the model using maybe an API or something, those processes you've done manually in your Jupyter notebook, you have to replicate them using either Python module or any other programming language you are using. You have to write everything again so that when the user sends in the data, it goes through those processes and gets the data ready for prediction. So you can see a lot of manual process in that space, right? But if you look at the characteristics of that, it means that you have manual, script-driven, and interactive, iterative process, right? Another thing is there's disconnection between the ML and the operation. The machine learning development is now uh, disconnected from the what? The operation, which is not good enough. Then because of that, there will be infrequent release of new iteration because it is very, very difficult for you to go back into your Jupyter notebook and start modeling again. Then you go back into your code base and start restructuring again. So there are a lot of manual process involved, right? Okay. There is no CI, there is no continuous integration, no continuous delivery. Deployment refers to prediction on service. Just you're serving your model as a service. That is only the trained model, not the entire system, which is wrong. You should be able to deploy the entire system. What I mean by the entire system is this. This is an entire system. Everything here is an entire system. But what you have deployed as level 1 is just the what? The ML code and a lot of manual process around this, right? Okay, I hope that is clear. If you go to level 2, look at level 2 now. You have this process, then you have this process written together at once. It means that your experimentation is not uh, is not disconnected from your what? Operation, right? You've put them together in a single what pipeline. It means that your pipeline can be used for both development and what production. I don't have so much time. I would have explained this diagram very well. Like, it's very straightforward. You have the data analysis, data validation, preparation, model training, model evaluation, and the likes of them until you get to what pipeline deployment. Now, when there is time for inference, time to get prediction, you don't need to go and start doing manual labor on this. Your incoming data can leverage on the operation that you've set up, which is the same thing as the what as the pipeline that is used. Just imagine you're using a pipeline for what? What's not pipeline? Each component has been set up to be useful for both development and what? And production. And you can see a trigger here. With me just setting a trigger like every 2 hours, always update my model. I don't need to go and start doing manual process of rebuilding the model in Jupyter Notebook and start doing manual work on my code base. So example of tools that you can use around there are TFX or SKLM pipeline. Those are the two common ones. So if you can study TFX very well, everything is components, and you just need to what integrate each component together, and you get your what work faster. So if you look at the characteristics of this, there is rapid experiment, right? The transition between steps is automated. So it means that your iterative process in machine learning deployment and development can be what? Can be speed up, isn't it? Also, there is continuous training. If tomorrow the model is depreciated, you can just trigger it to retrain itself. So there's continuous training and there's continuous what? Deployment. Experimentation is optionally symmetric. What do you mean of that? Your experimentation here is same thing as what? Production. You don't need to be writing twice. Your code are modularized, right? Okay, then there's continuous delivery of the model. The pipeline is also easy for you to deploy. Tools that you can use here are TFX, you can use SKLM pipeline and the likes of them. So in this case, you are not deploying a pickled saved model. You are deploying a pipeline. And in the pipeline contains different units and the model tied together, right? Okay, so if I look at level 2, which is the biggest, this level 2 is like you can think of what kind of system can I think of for level 2? Let's say like a Siri, you're talking about OK Google. Those are level 2 deployed application. It means that you don't even know when they've retrained the model, right? Okay, if you look at the architecture here, you see that it is similar to level 1, but the interesting part of this one is that you have the data analysis, but you have orchestrated experiments. What's the meaning of orchestrated? Managed experiments. Like you can use a Kubeflow, Airflow to do this, isn't it? A managed experimentation, right? You don't need to, do the manual process in that part or set just for you to configure everything down, and it is being managed. That is when you'll be thinking of Kubeflow, Airflow, Kubernetes engine, and the likes of them. Then you have your source code, then your source repository. And because of this, you can include CI/CD into it. And what comes out of that pipeline is a package, right? Is a complete package. And you can see that we can set our trigger here. So with incoming data now, we can then extract data validation can be done, data preparation, then we have our predictive service here. So this is the best architecture you can think of when it comes to matured architecture. But sometimes the problem you're trying to solve doesn't need complex what? Complex architecture. For instance, if the problem you're trying to solve is just to a one-time problem, like probably you might not be retraining the model, right? You don't need to do all this. You just need to stick to level 0 or level 1. But for streaming, that batch 4 that we discussed, example for streaming, it will be very, very difficult for you to use level 1 or level 0 for streaming architecture. It will be very, very difficult. So everything is tied together based on the problem you are what? You are solving, right? Let's look at the characteristics of this guy. Oh, let me quickly explain this. Now, after development and experimentation, what comes out is what? Your source code. You know, before, after the development and experimentation, what you get is your saved pipeline or saved pickled file. But now, what comes out is your source code. Now, with pipeline continuous integration, your source code can be packaged. That was why I said you can deploy as a what? As a package. Now, your source code can now be what? Your pipeline continuous integration can now result into what? Packages. Now, these packages goes into pipeline continuous delivery. You are delivering at what? At production. And that gives us what? Automated pipeline, right? And if you go down, you have continuous training. When you train, you have trained model, model continue delivery, predictive service. Then you can monitor what you are doing, right? Okay. Also, if you want to read more on how to uh, architect a production ML system, build adaptable ML system, what kind of system should I build for which problem, you can look at Medium for that. I have a wrote a part series, 4-part series on that. So especially for if you are using Google Cloud, but I believe that whatever knowledge you get here, you can cascade it or also use it for maybe AWS or Microsoft Azure platform and the likes of it. So you can just check it out at Okoyemi Bami on what? On Medium. Okay. Now, before we leave architecting production ML system, we have to talk about adaptable ML system. What's the meaning of having an adaptable ML system? When can we say that your system is adaptable? You know, like I said, look at this diagram. I have this leaf in this color, and you can see them that they are different colors. It's the same leaf transitioning from different color to another. It means that change is inevitable in machine learning life cycle, right? There is always change. You want to make sure that there is no bias. You want to make sure that your model is not degraded. You want to make sure that you are doing the right thing at the right time. In the workflow is always iterative, right? But ML systems should be designed in such a way that there is a room for adaptation. Like if this data did not come in this direction, can we still process it in this direction? That's one way in terms of what? Adaptable ML system to data ingestion, right? What if my user did not provide these particular features? Can the user still get the prediction at that particular time? You are building what? Adaptable ML system. You should be able to adapt to changes from the outside environment, isn't it? So it should be designed in a way that there is a room for adaptation for upstream model. Also, if there is changes in the, let's say, model appreciation and degrading, can your model workflow, can your architectural workflow adapt to retraining the model and serving the right model? That is building adaptable ML system now. Okay. Then the data source and dependency feature relation, input distribution. Like the input of a particular user distribution can be different from what you've used to train the model. Will your machine learning architecture be adaptable to that? So there are many ways you can design it to be adaptable to different things. And that's why we said MLOps is not for the faint of the heart, isn't it? Okay, now that is living architecture production ML system. If you now want to look at post-deployment activities, that is, you have your model in deployed now, but what are the things you need to be doing when your model has been deployed? That is what we call post-deployment activities. All you just need to do is monitoring. You're monitoring your model, the prediction. The model prediction performance is monitored to potentially invoke new iteration in the ML process. Like if you see that something is going wrong, right? Oh, this model is degraded. This is not the right outcome. This is not what I was expecting. You are monitoring your what? How your model is performing. How many requests per day? What's the latency value? Are there logs on error? Are there logs on user request? You are checking all this. So there are several reasons why you should monitor your model. First one is the relationship between your model and the input data might change. You have a model that you've deployed maybe probably 10 years ago, and you expect people to still be living the way they lived 10 years ago. No. You have to retrain the model. The model has what? Degraded rather, right? The distribution of the incoming data might be different from what you've used to what to train it. Another one is there's change in measurement and or user base, which changes the underlying meaning of variables. For instance, maybe when you're training the model as a 2017, there's a feature called maybe customer policy, right? Now the customer policy can be like maybe um, was referred or something. But in 2020, that customer policy has changed from what it used to mean, what it used to be in 2017, isn't it? So it means that you need to, if you don't monitor your system behavior currently, it means that your model will still be predicting but will be giving wrong results. That is why we need post deployment activities. In case something goes wrong, let's quickly do this. This is what is happening, how many this, how many that, logs and report, right? Okay, now I think we've spent a lot of time on production ML system. I would have loved to do some hands-on, but if we're going to be doing hands-on, we might spend like the whole day there. And there are great resources out there that you can look into. And this is just few. There are many out there on Google. Just search for what you're looking for. But a good place to start is on Medium, and I've written a lot of Medium article on that, so you can look at data science and machine learning in container. That if you don't want to do your training and deployment in your local machine, what if I train in a container like a Kubernetes container? I mean, in a Docker container, should I be using orchestrated containers? You can read this article out. Also, if you want to learn how to build production machine learning system, you can check building production machine learning system on Google platform. There are 4 of them. And also, if you're a JavaScript developer, you can look into how you can serve model in the browser. And this is a series on end-to-end machine learning using JavaScript in the browser, and TensorFlow.js and Danfo.js. So there are many tools out there. You can look at that. And also, you can also look at topic modeling open source tools. These are great resources that you can start looking into for different deployment options and how you can architect your model. Like for instance, deployment of machine learning model as a web application. The approach you have in that part is different from deploying a machine model as a service, as an API. The approach is different. Okay, and I will employ you to try to move from MLOps level 0 to MLOps level 2, whereby you have everything automated. You have everything in an orchestrated manner, and you are eliminating all possible form of manual labor. But mind you, don't forget that don't forget that the problem you are solving also determines the kind of architecture you use. Okay, for GitHub, if you need some code snippets on model architecture, model deployment, you can check GitHub, and the name is Okwemi Bami. There are also other GitHub repos that also have great resources that you can look into. So that's that on that. And on social media, you can just, if you have any question, you can tag on Twitter. You can message directly on Medium, and LinkedIn. You can connect on LinkedIn as well. Okay, so I hope we have a great time, and now I will just hand over to Lawrence, and I will stop sharing my screen.
Wow, wow, wow. This is really, really awesome. Thank you so much for me. Thanks for your time. Thanks for sharing your knowledge with us. I hope you guys will learn today. Okay? And I hope that subsequent times like having these is series, and we're planning to be having a session every month starting from January on building production machine learning systems. So, and the reason is because we're tired of building models and using them in our database. All right. So we'll be having subsequent times. We will also be having couples of other speakers um, from outside the country and those, especially from the industry, so to say. All right. So thanks a lot for your time. Thanks a lot, everyone. So I will discuss with Okpe so that we can have the slides available for those who are interested. But sorry, it has not able to record this session at the moment. All right. So thank you very much, guys.
Okay.
Enjoy the rest of the day.
Okay,
All right.
guys, thank you so
Yeah.
much. Enjoy the rest of your day.